Okay, so oleh sebab tu kita ada contention-based medium access. So, tapi yang ni mula-mula Aloha kan? Aloha tahu?
Tak pernah dengar tu.
Oh, kena dengar lah Aloha. Network pertama. Aloha network.
Oh, Random Access Protocol.
What is Aloha? Okay. Tahun bila tu? 1970s. Kan? Lama tu. Aloha mean hello. Halo. Alo lah. Aloha. Alo. Ada dua. Pure dengan slaughtered. Okay. Baca balik Aloha tu apa? Dia kalau belajar network mesti kena tahu Aloha tu. Kan? Bukan takat wireless. Wired pun kena tahu Aloha. Awal-awal apa nama networking kan. Okay. Internet. Okay. The history of internet. So orang kena tahu Aloha. Alright, nodes may initiate transmission at the same time, require mechanism to reduce the number of collision and to recover from collision. Example 1, Aloha Protocol use acknowledgement to confirm the success of broadcast data transmission. So, pada Aloha Protocol pun dah ada acknowledgement, allows nodes to access the medium immediately, address collision with approaches such as exponential backoff to increase the likelihood of successful transmission. Okay, and then kita ada satu pure kan, satu lagi slaughtered Aloha Protocol requires that a station may commence transmission only at predefined point in time. So the beginning of a time slot. So increase the efficiency of Aloha, introduce the need of synchronization among nodes. Okay, two forms of contention that are heavily used in today's network are carrier sense multiple access with collision detection, CSMACD detection, CD, and carrier sense multiple access with collision avoidance, CSMACA. Alright, so CSMACD is used by Ethernet, wired, okay, networks, while CSMACA is used by 802.11 network. Okay, both require station to listen for transmission and must wait until the medium is available. A CSMACD node can immediately transmit. If there is collision, it will detect it and the node will temporarily stop transmitting. Okay, 802.11 wireless radios are not capable of detecting a collision, cannot listen and transmit at the same time during their transmission. For this reason, 802.11 wireless networking use CSMACA instead of CSMACD to try to avoid collision. Okay, dengan detect dia takkan berlaku collision lah sepatutnya. Okay, dengan avoid maksudnya lebih baik lah kan, lebih baik lah. Faham tak? Collision detection maksudnya kita cari collision berlaku ke tak? Kan? Kalau berlaku, so kita kena retransmit kan? Kan? Bila ada collision kena retransmit balik kan? Ataupun kita bila ada berlaku, so dia akan tunggu sampai idle baru boleh initiate data transmission. Okay, so avoidance, so dia akan cari supaya tak ada berlaku, dia akan avoid daripada berlakunya avoidance, collision, sorry. CSMACD, sender first descends the medium to determine whether it is idle or busy. If If it is found busy, the sender refrains from transmitting packet. If the medium is idle, the sender can initiate data transmission. CSMACA, CSMCD require the sender aware of collision. Instead, CSMACA attempt to avoid collision in the first place. CSMACA initial access method for wired LAN, so half duplex mode, for example hub and coaxial cable. Sekarang kita pakai switch kan. Dulu kita ada hub, tak pakai switch, pakai hub. Pernah dengar hub?
Pernah.
Bukan hala hub tu. Dia macam switch juga kan. Kalau kata pakai tu keluar dulu 100 kan, 1 meg keluar seorang 10 je. 10 meg, 10 meg. Hub dapat seorang 10 saja. So procedure, listen to medium and wait until it is free. No one else is talking. Wait a random backoff time, then start talking. Oh, rupanya dia ada random backoff time. Okay, advantage, fairly simple to implement, functional scheme that works. The disadvantage, cannot recover from a collision. Inefficient waste of a medium time. Tak boleh recover from a collision. Okay, so carrier sense multiple access detection, collision detection. Kalau ada collision kan, saya rasa ada lagi ke ni? Kalau tak boleh nak pegang. Try tengok YouTube ni kan nanti dekat slide kan. So CSMACD improvement from CSMACA, CSMA, and also used for hub-based Ethernet half duplex, for example coaxial. CSMACA from CSMACA sini. CSMACD improvement from CSMACA. Okay, tertinggal sini. Procedure, listen to medium and wait until it is free. Then start talking, but listen to see if someone else start talking too. Walaupun dia start talking, tapi dia akan listen to see if someone else start talking too. If a collision occurs, stop and then start talking after a random backoff time. So advantage, more efficient than basic CSMACA, and disadvantage, require ability to detect collision ataupun voltage spike. Require ability lah kan. Kalau kata nak perlu yang lebih baik, dia perlukan lebih daripada yang biasa lah. CSMACA was used in now obsolete shared media Ethernet variant 10-base-5, 10-base-2, and in the earlier which are twisted pair Ethernet which use repeater hub. Okay, modern sekarang kita pakai apa? Kalau wired sekarang kamu ada apa? Twisted pair tu apa? Twisted pair tu apa tu? Kabel apa tu? Siapa tahu? Kabel network biasa lah kan? UTP kan? Yang kamu kata pakai Cat5, Cat6, Cat5E, Cat6. Sekarang Cat apa? Cat8 tak?
Cat6E kot silap. Cat6.
Cat7 pernah pakai?
Cat7 tak pernah pakai tapi pernah tengok.
Nak pakai kat mana kan? Tak ada dia punya network card kan? Cat7. Ada jual dekat Shopee. Cat7. Kalau hitam. Nak cucuk kat mana? Oh, boleh pergi 10 gigabit per second. Oh, dia based on laptop kamu lah. Kalau laptop kamu ada 10 gigabit network card, so boleh pakai Cat7. Tapi make sure dia punya router ni pula support 10 gigabit kan. Kalau tak, sama je, tak guna lah. Right. Untuk apa? Ada lagi Cat8. Oh, Cat7 10 gigabit per second. Cat8 boleh pergi 25 gigabit per second. Ataupun 40 gigabit per second. Oh, lagi laju. 4 kali ganda kan. 2 kali ganda atau 4 kali ganda dia boleh pergi. 2.5 kali ganda. Macam mana boleh kata dia adalah twisted pair? Sebab wire dia
Sebab wire dah berpusing.
berpusing-pusing kan. Right. Untuk apa tu dia buat pusing-pusing tu? Kan elektrik kan dia tak boleh, kalau kata ada dipanggil apa? Bukan aura dia punya. Kan kita kalau dekat dengan karan pun kita berasa dia punya tu. Orang panggil apa tu? Kadang tu benda tu boleh jadi interference. Okay. Dia punya panggil apa? Masa lagi panggil apa? Ya Allah. Kan kadang-kadang kita terkena sikit kan jatuh. Macam ni lah kamu pergi troli kat pasar raya tu kan. Kamu pegang dia punya yang besi tu, kamu sentuh dengan kamu punya siku ke, dia akan rasa macam ada current sikit kan. Panggil apa tu? Ada renjatan dia sikit kan. Dia renjat lah. Sebab dia macam sikit je. Right? So maksudnya benda tu boleh, it can become as interference. So that's why kita, sebab benda tu sebenarnya dia tak boleh leaking. Dia tak akan leaking sebab kita twisted pair pun dia dalam wire kan. Current tu dia split by wire kan, dia divide by wire. Tapi benda tu nak kata haba tak haba, dia panggil apa? Dia terlebih sikit lah kan, dia ada rasa sikit. Benda tu so dia nak bagi gangguan tu sekata, dia buat twisted lah, dia berpusing-pusing lah. Supaya tak mengganggu, supaya dia stable lah, macam tu lah kan. Supaya current dia stable lah dalam tu. Kamu YouTube je why UTP twist dia kabel kan. Baru nak tanya. Sekejap ada orang tanya 440. Okay, nanti saya balas lah. Okay, so dulu internet ada 10/5, 10/2. Bunyi je kan. Disable notification ke quit Telegram. Senang. Dengar kat phone je. (10/5, 10/2) and in the early version of twisted pair internet which use repeater hub. Dulu pakai hub lah. A modern internet network built with switches and full duplex connection no longer need to use CSMA/CD because each internet segment or connection domain is now isolated. Tak perlu risau sebab kita dah pakai switch boleh buat kerja benda tu. And then CSMA/CD is still supported for backward compatibility and for half duplex connection. Sekarang kita tak pakai lah kan. Okay, sekarang kita ada switch tu yang buat kerja kan. Dia nak hantar siapa dulu apa semua kan. Tak ada masalah kan. Right. Can we borrow media access method from fixed network to be used in wireless network? Problem in wireless network, a radio cannot usually transmit and receive at the same time. So signal strength decrease proportionally to the square of the distance or even more. The sender would apply CS and CD, but the collision happen at the receiver. It might be the case that the sender cannot hear the collision. For example, CD does not work. Furthermore, CS might not work. A terminal is hidden. Contoh bagi pun tak faham kan. So kadang-kadang collision happen at the receiver. Sebab kita ialah wireless, siapa yang boleh control, siapa boleh transmit lu, siapa boleh transmit lu. Kalau switch senang kan. Dia boleh switch kan? Nama pun switch kan, dia boleh switch kan. Okay, so dia tak ada masalah situ kan. Tapi wireless AP macam mana nak terima? Semua orang nak hantar mungkin serentak kan. So collision happen at the receiver. It might be the case the sender cannot hear the collision. Okay, so macam mana nak avoidance? So cara salah satu dia guna konsep CSMA/CA ni, maksudnya dia akan ada time lah, dia tambah time supaya tak ada berlaku ni lah. Carrier sense multiple SFV collision avoidance send the carrier to see if it clear. So maksudnya dia ada carrier sense and then dia kena sense dulu dia punya carrier tu dah boleh transmit ke belum kan. Okay. And then multiple access, many devices access the carrier at the same time. Collision avoidance, the sender before transmitter contact the receiver and ask for an acknowledgement. So kalau kata avoidance tu akan acknowledgement if not receive the request is repeated after a random time interval. So kat sini kita ada random time interval lah. So kita dah belajar tengok LSC kan, MAC layer dengan LSC logically control. Kita boleh faham lah sikit. Okay, dekat layer ni logical link dengan MAC layer kat layer berapa? 1 ke 2? Tak ingat?
Apa tu?
Logically LLC dengan MAC layer dekat layer berapa? LSL model. 1 ke 2 ke? Ataupun 3?
2. Data link.
2 data link kan. Okay. Nama pun logical link kan. Logical link, data link. Ada situ ada MAC ataupun physical address kan. Ada MAC layer. So dia ada buat kat sini. Ni senang nak faham lah. Contention-free service. Contention service. Point contention function PCF and then distributed contention function DCF. So kat sini bawah ni kita bahagilah macam mana untuk 802.11 A, B, G. Okay. Ini saya kata kalau kita belajar go deep, kita boleh hasilkan sesuatu kan, satu produk untuk wireless. Kita pakai je kan. Pakai pun tak faham dia punya konsep kan. A apa, B apa, G apa, N apa kan. AX, AC. Yang kita tahu kita kena ada network card chip yang sama. Lepas tu kena ada AP ataupun wireless router yang support kan. Kita tak boleh keluarkan router kita sendiri. Yang itulah kita tak belajar untuk hasilkan router. Okay, so continue on types of CSMA/CA according to the ITT640 802.11 2002 standard. There are 3 medium access control. So ada DCF, PCF and HCF. DCF is distributed coordination function. The fundamental and mandatory access method of the 802.11 standard has optional RTS, CTS. If many stations attempt to communicate at the same time, many collisions will occur, which will lower the available bandwidth and possibly lead to congestive collapse. So no QoS guarantees ataupun no priority traffic. So untuk PCF is optional access method, point coordination function atau PCF optional access method. So kita ada hybrid introduced in 802.11e. HCF hybrid coordination function for delay sensitive applications such as voice over wireless, LAN and streaming multimedia. So kita dah ada teknologi lah kat sini kan. Buat delay sensitive application, buat voice over wireless, LAN kan. Maksudnya kita nak kurangkan guna telefon, kita boleh guna atas network kita, apa nama talian network kita kan. So untuk DCF default method and mandatory method for 802.11 access, so is a contention-based method determining who get the transmit on the wireless medium next. So utilize multiple check and balance to try to minimize collision, allow for an 802.11 radio to transmit a single frame. After transmitting a frame, the 802.11 station must contend for the medium access before transmitting another frame. Okay, so kita start dengan wait for frame to transmit. So kalau kata medium tu idle, so dia akan wait IFS, dia punya frame dia kan. Kalau tak ada, baru dia hantar. So no, so dia nak hantar. Belum, dia kena tunggu dulu, wait until current transmission end. kalau ada. So kalau tak ada, macam mana kalau tak ada? Wait until current transmission end. So maksudnya dia kena tunggulah. Okay, dia kena tunggu. Dia tak adalah yes or no kan. Dia terus tunggu. And then wait IFS. Ada lagi, nampak? Adakah dia still idle? Yes, exponential backoff by medium and transmit frame. Oh, dia boleh transmit frame. Kalau dia idle, maknanya tak ada siapa-siapa, baru dia boleh transmit. Kalau tak, dia akan berulang wait until current transmission and kemudian dia perlu hantar lagi. Dia kan wait IFS pula. So kalau kata awal-awal lagi dia dah tunggu and then dan idle, tiba-tiba idle, so dia terus transmit lah. Dia transmit, dia akan patah balik ke atas lah, wait for transmit. When to transmit. Kalau kata the next, ada lagi kita nak transmit. Okay, so kat sini kita nampak ada backoff window. Macam kita dah ada satu slot time kan. So, inilah kita panggil contention windows. Right. So kita boleh tengok sini ada busy medium, ada next frame. Right. Basic access method lah. So there are four main components of DCF: interframe space, IFS, duration ataupun ID field, KS006 and random backoff timer. So IFS is a period of time that exists between intertransmission of wireless frame. So there are 6 types of interframe space IFS, which are listed here in order to shortest to longer. Kamu ada dia hantar sebagai RFIS atau reduced interference space. So ni kalau hantar ni dia akan ada highest priority ataupun guna short interference space SIFS. So this is second highest priority. PCF, DCIF, arbitration interference space. Yang ni used by QoS station, and then ada extended interference space EIFS used after receipt of corrupted frames. So the two most common interference space used are the SIFS and this IFS. As shown below, the EDCA frame is the highest priority frame, and the use of the SIF ensure that it will be transmitted first before any other types of 802.11 frame. So most other 802.11 frame follow a longer period of time called this IFS. Okay. So EDCA is a highest priority frame. Ini hantar apa? Unicast je kan? Yang semua hantar Unicast. So while the node is transmitting data, all other wireless devices must wait until the media is no longer busy. Betul. So AP waits for SIF before the sending the EDCA. So kalau tak ideal lah, so dia hantar EDCA kat sini. Station 2 must wait at least a DFS after the EDCA before sending data. Kalau dah siap, baru dia akan hantar send the data. Dia ambil masa sikit. Tapi benda ni jangan risau, dia bukan ambil masa second ataupun ni, dia mungkin dalam microsecond lajulah, tak perasan pun. Kan? Tak sempat pun kita nak buat apa-apa kan. Dah siap. So SIFS tadi ada untuk dalam DCF interference space IFS. So the short interference spacing, highest priority for CTS. Polling response SIS time and slot time are fixed per PH1 layer. Okay, so tengok dalam 10 microsecond and 20 microsecond, bukan millisecond lah, microsecond. Per juta, betul? Per 1000 millisecond, per juta adalah 1 bagi, kalau 1 microsecond maksudnya 1 bagi sejuta saat. Macam tu. 1 bagi sejuta saat, 0.001. Okay. Kalau kira dalam bentuk gram pula macam mana? Boleh?
Gram saya. Macam ni kita.
Microsecond boleh, microsecond dengan second lah kan? 1/juta second. Kalau gram boleh ke? Kalau gram dapat RM1,800 kan? Kalau kilogram dapat ribu-ribu lah kan? RM1,000, RM2,000 kan? Kalau ikut masa lama, 11 tahun lah, 11 tahun. Kalau kilogram dia lama, dia 11 tahun. 11 tahun dia bela ikan siakap. And then PIFS ataupun PCFS. Okay. So P ni sebenarnya PCF kan? PCF IFS. So kalau D pula DCF IFS. Okay. Kan? Medium priority for time bounded service using PCF. So PIFS time sama dengan FIS time plus slot time. Dia tambah slot time. Kalau DCF IFS ataupun DIFS is a lowest priority for asynchronous data service. So plus SIF time plus 2 times slot time. Tambah lagi slot time 2 kali. Doublekan slot time. So kena tunggu lagi lah. Okay, sebab dia ada lowest priority. Okay, so sini kita ada IFS, RCK, RTS, CTS. Second or subsequent service data unit of a fragment bus is a priority level, high priority. Kalau kata yang medium, so kita ada PIFS, time bounded data frame, DIFS, time incentive data packet. So medium busy ni kan PIF, DIFS. Okay. Slot 20 microsecond. Yang ni mana paling cepat ah? A lah kan?
A.
Tapi quotation Windows dia 15 slot saja. Okay. Second one on DCF is duration ataupun ID field. Duration ataupun ID field is one of the field that in the MAC header of N802.11 frame. All station monitor this field. It indicates how long the RF medium will be busy before another station can contend for the medium. So the duration ID field contain a value from 0 to 32,767. Ataupun kita ada 32,768. kan? 207. Betul? Asal 207, 216 4.2 bilion, 208 65536 207 lah. 32768. The duration ataupun ID value represents the time in microseconds that is required to transmit an active frame exchange process so that the other radios do not interrupt the process. A client that is transmitting the data frame calculates time to transmit this frame to the AP or to the client if an AP, ataupun kalau AP yang nak send, so dia akan transmit to the client, and then the returning SCK ataupun the times in between frame, IFS interference spacing, ataupun all station update dia, and AV network allocation vector timer. Example, suppose Mata is sending a frame to Josh. Vivian also receive frame with NAV sama dengan 10 millisecond. So does not attend transmission until the NAV has committed to 10. So ini tugas NAV lah. Okay, adik NAV sama dengan 10 millisecond. So semua orang kena tunggulah. Okay, Vivian walaupun dia ada benda nak hantar, so dia kena tunggulah kan. Sebab kita ada this and NAV. NAV akan hantar dapat suara semua kan. Okay. So padahal mata yang nak hantar dekat JAWS saja kan. Tapi Vivian tak dapat lah data tu kan. Dia hanya dapat NAV. Okay, third one is a carrier sense. The first step that N802.11 CSMACA device needs to do to begin transmitting is to perform a carrier sense. This is a check to see whether the medium is busy or not kan. Sama ada kalau idle ataupun tidak kan. Kalau idle maksudnya dia tak busy lah. Kalau tak idle dia busy lah itu. Virtual carrier sense ada juga virtual carrier sense. Layer 2 carrier sense. So this virtual carrier sense use a timer mechanism known as an NAV tadi. Can a listening radio listen a frame transmission from another station? It looks at the header of the frame and determines whether the duration ID field contains the duration value or the ID value. If the field contains a duration value, the listening station will set its NAV timer to this value. The listening station will then use the NAV as a countdown timer, knowing that the RF medium should be busy until the countdown is 0. This process essentially allows the transmitting 2.11 radio to notify the other station that the medium will be busy for a period of time. Duration ataupun the station that are not transmitting listen and hear the duration, set a countdown timer and wait until their timer hits 0 before they can contend for the medium and eventually transmitting on the medium. The station cannot contend for the medium until its NAV timer is 0. Nor can station transmit on the medium if the NAV timer is set to the non-zero value. Satu apa ni? Virtual carrier sense. Okay. Physical carrier sense. Dia ada bagi pada dua layer kan. Layer 1 carrier sense. Second carrier sense method is in case a station did not hear the other radio transmitting and was therefore unable to read the duration ID field and set its NAV in layer 2 carrier sense. Physical carrier sensing is performed constantly by a station that are not transmitting or receiving. When a station performs a physical carrier sense, it is actually listening to the channel to see whether any other transmitter are taking up the channel. Physical carrier sense has two purposes: to determine whether a frame transmission is inbound for a station to receive. If the medium is busy, the radio will attempt to synchronize with the transmission. To determine whether the medium is busy before transmitting, this is known as the Clear Channel Assessment or CCA. The CCA involves listening for RF transmission at the physical layer. The medium must be clear before a station can transmit. It is important to understand that both virtual carrier sense and physical carrier sense are always happening at the same time. So virtual carrier sense is a layer 2 line of defense, while physical carrier sense is a layer 1 line of defense. If one line of defense fails, hopefully the other will prevent a collision from encountering. Tu punya kan, dia ada dua layer kan. Okay, layer 1 in physical, layer 2 virtual carrier sense. Yang keempat, kita ada random backoff timer. Okay. And 802.11 station may contend for the medium during a window of time known as a backoff timer. The station select random backoff value using a pseudo-random backoff algorithm. The station choose a random number from range called a contention windows. So after the random number is chosen, the number is multiplied by the slot time value. Slot time use sizes dependent to the physical layer specification. Okay, PHY in use DSLS atau FDM atau etc. The random backoff timer is the final timer used by station before it transmits. When the backoff time is equal to 0, the client can reassess the channel, and if it is clear, baru dia akan begin transmitting. Okay, Vivian and Josh might want to transmit frame when mata transmission is complete. Dua-dua nak hantar kan. Both sessions should have the same NAV value. The both will physically sense when the media is idle. There is high probability that both stations will attempt to submit when the medium become idle cause a collision. To avoid this situation, they also use random backoff timer. So maksudnya dua host ni, Vivian dengan Josh ni nak hantar kan. So dia akan sense dulu kan. Okay, dia akan sense dulu. Dua-dua tengah tunggu. So tiba-tiba kalau kata carrier tu dah idle, so of course dua-dua akan hantar kan. So to avoid this, so kita akan ada satu lagi nama dia random backoff algorithm. So dia akan bagi random time baru boleh transmit ke sense, transmit kan selepas sense. So berapa banyak yang dia random, dia ada list lah value yang dia bagi dalam contention windows. So contoh Vivian ni dia buat select random backoff time, dia dapat CW sama dengan 4. So and it reads the selected number of slot time before transmission. After 4 slot time, sebab dia dapat 4 tadi kan, CW sama dengan 4. Random tu kosong sampai berapa, so dia akan dapat 4. So yang lepas dia yang keempat tu dia baru boleh transmit. Okay, after 4 slot times pass, Vivian can transmit. Barulah Vivian can transmit. But what if your station has random backoff time of 2 time slot? So Vivian akan update her NAV that with new value. Vivian must wait for NAV to decrement to 0 and her PHY to report the medium is available again before she can resume her backoff. In this example, Vivian must wait additional 2 slot time before attempting to transmit. So Vivian dengan Josh ni nak hantar, dia akan wait for transmit. So dia tunggu idle ke tak kan. Kalau kata tak idle, so dia tak boleh transmit kan, dia kena wait until current transmission end dan wait lagi, and then tengok adakah still lagi idle. Kalau kata ada lagi data yang lalu tu, maksudnya dia tak idle lah. So dia akan tunggu lagi wait until current transmission end. So kalau kata dekat atas ni pun dia dah tunggu memang idle. So dia akan wait IFS lah. So selepas wait IFS, dia akan tanya dulu. Dia tu tak atas ni, dia akan tanya adakah still idle. Kan? Dia tak boleh suka-suka hati terus hantar. Dia ada random backoff timer. So in addition to this, the ITT640 2.11 year 2012 kan, standard define as condition optional medium access method known as point coordination function, PCF lah, point. So this access method is a form of pooling. Point ni pooling lah, kita keliru lah, P ni pooling kan. The AP perform the function of the point coordinator because the AP is taking the role of the point coordinator. The PCF medium access method will work in only basic service set atau BSS. So PCF cannot utilize in an ad hoc network because no AP exists in independent basic service set ataupun BFS. Okay, because pooling is performed from a central device, PCF provides managed access to the medium. So PCF was never adopted by wireless LAN vendor. In PCF, the access point briefly takes control of medium and put in the client in order for PCF to be used. Both the AP and the station must support it. The PCF enable PCF with the function. The AP will alternate between PCF mode and DCF mode while the AP is functioning in PCF mode. That time is known as the contention-free period ataupun CFP. During the contention-free period, the AP pulls only current in PCF mode about the intention to send data. This is a method of prioritizing, priority lah. Kan, nak bagi priority dekat client. While the AP is functioning in DCF mode, that time is known as the contention period. Hybrid coordination function HCF 802.11 Equality of Service Amendment added a new coordination function to 802.11 medium coordination, so known as hybrid coordination function HCF. So this HCF combines capabilities from both DCF and PCF and add enhancement to them to create two-channel access method. So dua lagi keluar daripada HCF, EDCA dengan HCCA, Enhanced Distributed Channel Access ataupun HCF Control Channel Access. DCF and PCF media contention mechanism discussed earlier allow for an 802.11 radio to submit a single frame. After submitting a frame, the 802.11 station must contend for the medium again before transmitting another frame. HCF define the ability for an 802.11 radio to send multiple frames when transmitting on the RF medium. When a HCF compliant radio contend for the medium, it receives an allotted amount of time to send frame. This period of time is called transmit opportunity atau TSOP. Transmit opportunity. During the transmit opportunity TSOP, and 802.11 radio may send multiple frame in what is called a frame burst. Ni frame burst. Okay. A short interframe space SIFS is used between each frame to ensure that no other radio transmit during the frame burst. Maksud asal dia kan, macam CSMA. Enhanced Distributed Channel Access is a wireless medium access terlajak lah. That provide differentiated access that direct traffic to 4 access category QoS priority queues. EDCA is an extension of DCF. The EDCA medium access method prioritizes traffic using priority tags that are identical to 802.1D priority tags. Priority tags provide a mechanism for implementing QoS at the MAC level. So different classes of service are available represented in a 3-bit user priority field. Ada 3 bit lah. Kelas 1 lah. In an ITT640 queue header added to an Ethernet frame. 802.1D tak pernah dengar kan. Enable priority queuing, enable some Ethernet frame to be forwarded ahead of other within a switched Ethernet network. Figure below this depicts 802.1D priority tags from the Ethernet slice that are used to direct traffic to access category queue. So 802.1D prioritize network traffic mana satu yang priority, voice ke video ke best effort background. So dia akan dalam next TSOP tadi kan. Okay, next EDCA define 4 access category. Ada 4 pula dah, apa tu? So based on the 8 UPs, the 4 category from lowest priority to highest priority are SCBK. So ni paling lowest sekalian adalah untuk background. SCBE, best effort. And then SCBI and SCBO. So adalah top high priority lah. For each access category, an enhanced which are DCF known as enhanced channel access function, EDCAF, okay, is used to content for a text OP. Frame with the higher priority access category have the lowest backoff value and therefore are more likely to get a text OP. So next, HCF control channel access is a wireless. SCCA is a wireless media access method that use a QoS aware centralized connector known as a hybrid connection. So still lagi dalam hybrid HC, which operate differentially than the point connected in a PCF network. The HC is built into AP and has a higher priority of access to the wireless medium. Using the higher priority level, it can allocate the SOPs to itself and other stations to provide a limited duration control access space or CAP, bukan cap price lah, cap saja, providing contention-free transfer to KS data. Oh, panjang punya kan? Contention-based untuk C coercion, carrier sense, multiple access, CSMA. Alright, so sampai dekat ACF control channel access ataupun HCCA. So kita akan pergi ke next Macau. Mula kita tengok Macau ni apa? Okay, Macau stand for multiple access with collision avoidance. Sama je ada collision avoidance. Kan? Cuma dia tak ada carrier sense saja, nampak tak? Faham tak? So CSMA/CA maksudnya buang CS. Jadi MACA. Okay. So use in ad hoc network, maksudnya network yang tak pakai IP direct, macam kamu nak laptop ke laptop tapi tak ada IP kan, boleh. Okay, so where CSMA with RTS, CTS not suitable and those carrier sense not needed. CS tak perlu. Carrier sense tak perlu. EU RTS, CTS ataupun short signaling packet mechanism similar to CSMA to avoid collision. Untuk CA sama je. RTS request to send, sender request the right to send from a receiver with a short RTS packet before it send a data packet. CTS ataupun clear to send. RTS tadi apa? Request to send. So CTF, the receiver grants the right to send as soon as it is ready to receive. So meanwhile, note that here RTS should remain silent in avoid conflict with CTS. Note that here CTS should keep silent until the data transmission is complete. So signaling packet contains sender address, receiver address ataupun packet size. So MACA avoid the problem of hidden terminal. Tak macam CSMA tadi kan. So A and C want to send to B, A send RTS. First C wait after receiving CTF from B. So MACA avoids the problem of exposed terminal. So macam ni, B want to send A, C to another terminal. So now C does not have to wait for it cannot receive CTF from A. So hidden node problem. A send B, A send RTS to B. C cannot listen to the RTS since out of range. Tak boleh terima. C also want to send data to B. If C send RTS to the same time with A, collision will occur at B. So upon receiving RTS from A, respond with CTS. Now C can hear the CTF sent by B to A since it within this. Within the RTS and CTS, there is information about the data that will be sent by the initiator node ataupun node A in this example in the form of duration. Node C will refrain from accessing network using this duration information. Okay. So expose node problem lah. In wireless network, the expose the problem occur when a node is preventing. Kamu sangat saya kan? Prevented from sending packet to other node because the co-channel interference with a neighboring transmitter. Nak habis dah sahabat. MACA patut MACW ada belakang. Consider an example of 4 nodes labeled R1, S1, S2, R2, where the two receiver R receiver, S sender are out of range of each other, yet the two transmitter S1 and S2 in the middle are in range of each other. Here is a transmission between S1 and R1 is taking place. Node S2 is prevented from transmitting to R2 if consider element label R1, S1, S2 in the middle are in range in each other. Here if a transmission between S1 and R1. Okay. Node S2 is prevented from transmitting to R2 as it concludes after carrier sense that it will interfere with the transmission by its neighbor S1. However, note that the R2 could still receive the transmission of S2 without interference because it is out of range S1. S2 dengan R2 want to transmit tapi dia ada R2 could still receive the transmission of S2 without interference because it is out of range of S1. R2 dengan S1 out of range. If a node here no respond to an overheard RTS, then it may assume that the intended recipient of the RTS is either down or out of range. Okay. Station C has recently sent traffic to station A. It knows how much power is required to reach A. If C overhears station A responding to with a CTS to a third station B, then C needs to remain completely silent for the required interval. It need only limit its transmitter power to say 20 decibel below the level needed to reach A. Okay. So during this time, it would be free to transmit to any station that it could reach with the reduced over level because its signal at A would be overridden by B signal. This analogous to the people at the cocktail party continuing their conversation in whisper instead of stopping completely while their neighbor are having conversation. Orang bercakap pun kita bercakap kan. Okay, so MACA. MACA-W ni untuk wireless. Tambah W untuk wireless. Tapi W untuk wired pun boleh kan W. Tapi W ni untuk wired ke wireless? So khas untuk wireless lah. Okay, MACA atau Macau ni. Burung Macau. Tengok cerita apa. Yang biru tu panggil apa? Blue tu. Angry Bird.
Apa ni, Rio ke?
Rio. Macau kan. Teringat saya. Rio 1, Rio 2. Rio 3 dah tak ada?
Tak ada.
Yang dua tu cerita siapa? Oh, anak-anak dia kan. Dia balik rumah mertua dia. Terkejut kan jumpa ayah dia kan. Yang perempuan tu pula. Yang betina tu. Burung betina jumpa ayah dia balik kan. MACA-W has been developed as improvement to Aloha Protocol and used in ad hoc networks. So RTS, CTS, data, SCK, messages are exchanged between terminal, no carrier send, no collision detection. So hanyalah collision avoidance. Sender send RTS, receiver send CTS, sender send DS, sender send data, receiver send SCK, and station hearing DS differ until end of data transmission. So dia ada backoff mechanism juga. So kita pakai exponential backoff with improving fairness and throughput. Okay, so assume that node A, mana node A? Sini. Has data to transfer to node B. Nak hantar ke node B. Node A initiate the process by sending request to send frame RTS to node A, B. The destination node B reply with clear to send. So B akan beritahu boleh send tak boleh send. So senang lah kan, dia tunggu, dia nak hantar kat siapa, dia tunggu kawan tu reply dah boleh send kan. Okay. So node A send data after dah clear. Node A send data after successful, ada EDCA pula. Node B reply with an endorsement frame or EDCA. If node A has to send more than one data frame, tapi kalau dia data dia banyak kan, dia hantar kan, dan dia harus kena wait dululah. Maksudnya dia tak boleh hantar semua sekali tak habis. Dia if maksudnya dia hantar tak habis lagi kan. So yang belakang tu dia kena wait random time after each successful data transfer and compete with adjacent node for the medium using RTS atau CTS mechanism. Any node overhearing an RTS frame, for example node F and node E, okay, refrain from sending anything until a CTS is received, or after waiting a certain time if the capture RTS is not followed by the CTS, a maximum waiting time is the RTS propagation time and the destination node turnaround time. So any node C and node E overhearing a CTF frame refrain from sending anything for the time until the data frame and CK should have been received. So plus random time. So both the RTN and CTF frame contain information about the length of the data frame, Hence, a node use that information to estimate the time for the data transmission completion. So before sending a long data frame, node A send a short data sending time frame. Ada lagi dia hantar DS which provide information about the length of data frame. Oh, dia beritahu berapa banyak dia nak hantar. Every station that overhear this frame know that RTS CTS was successful, and overhearing station node F which might have received RTS and DTF, but not CTF defer its transmission until after the EDCA frame should have been received plus a random time. Oh, habis juga kita sampai MACAW. Okay. Multiple access, collision, avoidance for wireless. So any question?